I made up this problem of a tax on buyers just to make sure you knew how to do this kind of problem. Really important application of supply and demand analysis. Anyway, we have this supply demand system. Quantity demanded equals 100 minus 3p. That's the demand curve in algebraic form. Quantity supplied equals just p, the supply curve in algebraic terms. And then we're going to do a case where a tax of $12 per unit is assessed on buyers. And the way to do these, first work out the market equilibrium without the tax, then work out the market equilibrium with the tax, and then graph the market. This isn't the only way to do it, but this way works. And then finally conduct the welfare analysis. Actually, let's do everything let's do the complete welfare analysis, just so you see how that's done. All right, here we go. The market clears where quantity demanded and quantity supplied are equal, and we know that the demand is 100 minus 3p, and we know in equilibrium that has to equal the quantity supplied, which is p, and we can solve that for p equals 100. P is equal to 25, and Q is equal to 25. All right, so that's the market case, and then that's without the tax, of course. Now let's do the market with the tax. Here again, our equilibrium condition is that the quantity demanded is equal to the quantity supplied. But now the demand curve is still QD equals 100 minus 3p. And the supply relationship is still the same. Quantity supplied is equal to the price that buyers get, but that sellers get. But now P is the price buyers pay, but sellers get that price less the tax. So this is the key step in solving a tax problem. Realize that you could as easily let P stand for what sellers receive, but I always make it stand for what buyers pay. And then sellers receive the price buyers pay less the tax, which is 12. So that's it. Now we just do the same steps we did before. Quantity demand equals quantity supplied. 100 minus 3p equals p minus 12. We add 12 to both sides, add 3p to both sides. We get 4p is equal to 112. P is equal to 28. And Q is equal to, supply curve is easier, Q is equal to 16. And there we have the algebraic solution for price and quantity in both cases. Now let's move on to the welfare analysis. So the welfare analysis, the welfare analysis is easier if you graph, and graphing is easier if you calculate out the inverse demand function and supply function. So the inverse demand curve, we can add 3p to both sides of the demand curve and subtract q from both sides of the demand curve, and then divide through by p. And when we do that, we get p equals 33.33333 minus q over 3. And the supply curve, well, the supply curve, inverse supply curve is really easy, right? P equals quantity supplied. All right, so graphically, what this means is we've got this quantity units per month, I don't think I ever defined this good. Price, dollars per unit. And then we have this demand curve that runs from, that's a straight line, believe it or not, 33.33 to 100. Slope of -3, and the inverse demand has. And then slope of -1/3, I hope I said. Now the supply curve is just a ray from the origin with a slope of 1, and 1 is a much steeper slope than 1/3, 3 times as steep, one might say. Yeah, I didn't quite draw it steep enough probably. But anyway, now we're ready. We can just implement our algebraic solution here. 25 and 25 was the market clearing price and quantity without a tax. Let's solve for the tax. Remember, we're looking for a quantity where the price paid by buyers is exactly 12 higher than the price received by sellers, and that comes at 28. Price buyer pay of 28, and sellers receive 16. And there we have it. Now, I mean, I could calculate a bunch of areas. I'm going to take a little bit of a shortcut. And if you're in a pinch on an exam, usually this is okay. I don't dock anybody points for doing it this way. What you can do if you run out of time to calculate rectangle areas and triangle areas, you can just keep track of areas by labeling letters. So I'm just going to label every area that I'm going to need. And I've done this before. This isn't my first rodeo, so I sort of know what areas I need and what I don't need. But when you're first doing this, first learning how to do this, it's common to not know that. If you over-label areas, no big deal. You just don't ever refer to some areas that you have labeled. Let's do consumer surplus, producer surplus, government revenue. This is the complete welfare analysis and the total. And let's do it in the no tax case and the tax case. And then we'll look at the change. That's a capital delta, Greek letter delta. And we'll do it in terms of just these lettered areas, not algebra, because not numerical areas, because I'm going to run out of time if I do it differently. Consumer surplus in the no tax case, that's ABC. Producer surplus in the no tax case, that's DEF. Stop the screencast and make sure you know where those came from. There's no government revenue because there's no tax. A, B, C, D, E, F. And then I guess I'll do a different color for the tax case. In the tax case, notice that consumer surplus goes down to area A. Producer surplus goes down to area F. And the government collects $12 a unit for 16 units. And so government revenue is BD. When we calculate up that total, A, B, D, F. Notice that consumers lose an amount equivalent to area BC. We could calculate that out if we wanted to. You can do that at home. Producers are worse off by an amount DE in their loss surplus. Government now has BD to spend on goods and services provided by government, and we see that this area CE is lost completely. That's deadweight loss. Negative CE is deadweight loss. And the way when you do welfare analysis this way, the deadweight loss generally is in this bottom right corner of the table. We can actually calculate that. Deadweight loss is equal to 1/2 times 12. I'm going to turn that triangle on its side. So base of 12 and height of 9, and that's equal to 54. One more point to make before I close here. Notice again this incidence. The tax was collected from buyers, but the incidence of this tax is mostly on sellers because they have the less elastic function. The demand curve is more elastic in absolute value than the supply curve. So sellers pay a quarter of the tax, right? Buyers pay a quarter of the tax. Their price went up by $3, and that $3 is 1/4 of the $12 tax. Price sellers receive goes down by 9, that's 3/4. So if we wanted to do incidence of this tax, going to get noisy here, on buyers it's 25%, and on sellers it's 75%. And notice again that the economic incidence of the tax is independent of the legal incidence. And that's an important point that's lost in the public debate. You'll see in Oregon as we debate this Measure 97 this fall. All right, let's call that good enough.